Yes, let's do this into week 4. First one from week 4, chapter 15 exercise. I don't really have any imagery up for this, right? Because it's just, there is the video for it. From old Scott Hansen. Yeah. It looks good. I've watched it. Let's see. So I'm just going to start. To do a weldment, generally you're going to have parts, right? So the first thing is to create a couple parts to weld together. And so it's going to be a new standard part. And it's just a simple rectangular part. It's like a 16th of an inch thick. So, and it's like 1 by 4, really small part actually. Um, that is pretty common. Like some of this, what we'll do this week with these problems are kind of small, just small metal parts. And I visualize that as almost more like when welders practice, they just weld small coupons is what they call it, which are just small, like sometimes they're like 6 by 6, 6 by 4 rectangular sheets all cut up, and then they can assemble the joint types they want to practice, kind of the joint configuration, and then and then they can perform their welds, and they can analyze their welds, and they can cut up those coupons into strips and do like destructive testing on their welds. That's pretty common of how welders practice their welds, and they actually destructively test the integrity of their welds. There's also non-destructive type tests as well. We can X-ray welds, and we can ultrasonic test welds, and we can like use some dye penetrant testing. So there's a lot of like non-destructive ways that welds get tested. And then sometimes to like vet that this procedure works good, which means like a welding procedure just means we've identified a process, like one of the processes we were talking about yesterday, and then we've identified a joint type, and that process and that joint type configuration, we can have a welder like practice that and then test it. And part of that testing would be to destroy the weld, bend it in half. And they really destructively test it beyond the point that it would ever like fatigue in service, or beyond the point that it would ever, unless it's a total building collapse or something, but it's really going to be tested beyond what it should ever like see within its service life. And it still should be structurally sound beyond its really service, intended service design. Yes. And so they test these things all out, and then they can write what's called a weld procedure. And then they can say, okay, these things now have to be according to this process, this material type, this joint configuration has to be welded in this sequence. And then we call this like a welding procedure, and then we issue it out. We don't really do that. Like certified weld inspectors do that, and welding engineers, which are generally certified weld inspectors, also as part of their schooling probably. They write those procedures for others to follow. That's why it can be hard, or that's why it can be in some engineering and design uh, uh, groups. They may avoid weld symbols unless you have some subject matter expert on your team, whether it's a weld inspector or it's a welding engineer. They're going to be the best way to communicate from engineering and design down to something that makes sense for the fabrication team. It's really easy to mess this up. And in fact, this exercise 15 is not this is not a viable weld. And we'll talk about why. I'll just talk through why. But and some of the rules of thumb that will help us you know, kind of know a little bit more about what we're doing here. But what he does is he just creates kind of a coupon part, I would say, something, a couple little, like he's just going to make a little weldment that's going to get welded together, maybe for practice or for procedure evaluation. And so that's just, I just started a sketch. We'll just start a sketch on the XY plane, I guess. Yeah, XY plane. Hey, that's just something I just noticed. That you saw. Hey, I'm gonna keep my sketch. I'm just finishing it. This is new. This is a little bit new to me, and I just barely even noticed that functionality. I'm used to turning on my planes a lot, but that just caught my eye. That I see that Inventor, when I go to start SketchUp here, it like turns on everything for me. That's pretty nice actually, because I don't always just want them on. It allows me to like quickly. And maybe you guys have noticed ever since you've been like, why does he turn them on, man? I don't. One version of Inventor used to just have the planes on. You just had to toggle them off. And then one version of Inventor didn't seem like this one didn't. They weren't automatically on. But maybe this has always been there. I don't know. I can learn new things all the time. I'm looking for the XY plane sketch. I noticed that when I do that, it just started that sketch, and then my planes turned off. So that's cool. That's what you're doing. That's great. Just so you identify where in space you're modeling. I'm going to do this rectangle, which is just like a 1x4 rectangle here. So these four this direction and one in this direction. So 1 inch is a really small coupon, by the way. That's not very much material. Usually when welders practice, they might be something longer, like a 4x6 or something, or a 3x6. And then they'll trim it down a few times. You can still weld this, but I'm going to constrain this in space here. So I don't think he does this on his video, but this is what I always do. Well, I'll do maybe like a horizontal constraint to middle, vertical constraint to there. And that's this just a 1x4 rectangle part. I've constrained it, finish it. He extrudes it 1/16 of an inch. Really small part as well. It's like sheet metal. So he just extruded this 0.0625. That's 1/16 of an inch. I'm going to put this centered over my planes here on my extrusion. So my sketch will be buried in the middle. So, and just so you know, like this is 1/16 of an inch. So sheet metal is one kind of, and we talked about this a little bit in some of our chapters, but at 3/16 is kind of like 3/16 thick. That's kind of where sheet metal turns into, I think it's technically like maybe 1/4 inch, like 0.25 in thickness. From that point on, maybe the steel distributors think of that as plate, and maybe 1/4 inch and under, but really 3/16 and under is sheet metal, and it's definitely it's formed differently in the manufacturing. For sheet metal, I can get even different finishes. And so he's in a sheet metal realm here, even though we're in a standard part. Just so when I see something that's a 1/16 of an inch thick, that is sheet metal to me. It's really thin. 1/16 is really thin. Okay. Why this matters is because if we think about welding, these things matter. And so he just makes this one part, and then he saved it. We'll just save this as this is in week 4 for me. Just so you know, week 4, I have these 3 subfolders, which is really, I think I've mentioned, this is how I definitely build my folder structure. And so for week 4, I built 3, I go into my week 4 and I have an assemblies folder, a drawings folder, and a parts folder. This is going to help me anything I do in week 4, we'll have several different parts. I'll just dump them all in the parts folder. All my assemblies for these little weldments will be in the assemblies folder, and I'll have the drawings for each of them in their own folder. So it's just you get quite a few different assemblies and parts. And so it can be kind of hard to organize or find which one's which. But I saved mine in my parts folder, and this was exercise. I just called it part 1. I have to just change mine slightly. Put some designation so I don't lose it as well. But part 1 for this, and then he just went to the we're gonna open up a new type of an assembly, and it's a weldment. Instead of the standard assembly, we're gonna use a weldment. Although it's very similar. This is an ANSI weldment. Yeah. Create it. It doesn't look too much different, other than I think default when it comes into it, you'll be on the welding tab. So it adds that one tab here to your above your ribbon menu. Normally you'd be coming in at the assembly tab and be ready to place, which is where I still need to go. So I'm going to toggle over to the assembly tab, go ahead and place in that part that I created from my folder. There's mine. We end up placing 4 of these because he ends up making kind of 2 different weldments in one here. So I think he places 4. If your assemblies are like mine, I like to turn on my shaded with edges here. Doesn't ground and root anything or even place one. He kind of keeps them free floating in this model space. That works for me too. What we want to do is just join them together to make a T. And so he makes T fillets out of here. And so that's why I feel like the next thing you should think about when welding is kind of the joint designs. And this is considered like a T joint. And then maybe, if you wrote it out, it'd be like TE joint or something. T joint. Why do I need 4 of them? Because I'm gonna weld them. We're gonna act like we're gonna weld these together, and we're gonna make like 2 coupons, is what I kind of call this. So what I'm gonna do is I'm gonna assemble these. I'm gonna constrain these, and so I end up putting like one of these edges. You can pick any of these parts, by the way. So I'm just gonna pick one like skinny edge here, and I'm gonna mate it to the face of this one. That's essentially creating the T joint configuration. Real standard way to join metals is like to T them together, just butt one into the other, but one's face to edge kind of. That's a T joint. Say okay on this one, I'll apply it, and then we just line them up end for end here. this. Of course, they need to be flush. I'm going to change that solution and say apply. And then he aligns his with a dimension. I just end up aligning mine plane to plane here. So I think the way I've done mine is, let me just blast that. It's just whichever parts I'm working on, which I can identify really quick in my list. This one, maybe I just want to know its origin planes, and this one, its origin planes. And I know I have a plane to plane relationship that will align these up centered. Like there's my center plane there. And I'm going to apply it to this one here. That's the center plane of that one. That's just because I constrained them in their environments that way. So I have these, maybe they're going to be flush. Got it. Okay. I think he uses a dimensional constraint. I just chose to use a plane constraint, so it's actually centered. And oh yeah, let's do it. So it is like for my last constraint, that is. Yeah. I identified from my list which ones are which origin planes I need. And I'm just constraining this plane. It's like the thickness plane right here. I have a center plane in this one right there. And then if those are flush constrained, I can just hit OK. And now these two are constrained together, but they're not constrained in monospace, right? Oh, try the other solution. Always say edit that. Like if you always get the conflict of your just and then so just say edit and then go in and choose a different solution. And it probably is just needing to be, the opposite one that you have. Yeah. Don't delete those. Just edit them. Keys. It'll even allow you to force it to constrain, but then you'll see that the constraints will blow up on and it'll make you want to have to fix them. So you could still apply that, and then even if you know it's right, but you're going to fix another one to actually make it right, like you can just force a constraint and then and then fix the blow up. If it's conflicting another constraint and you want to change that one instead of this one, yeah. I mean, that gets complicated. And I'm gonna do the same thing. I'm gonna make the same little configuration with this set of coupons. This is what a welder would do in their little booth while they're practicing. They'd have to cut flat strips like this and then create the joint they want to practice welding. And this is a real common joint that welders practice. Like some of your first welding might be this is going to become a fillet weld, is what we're going to call it. I'm going to apply this. It's a T joint, but we're gonna perform a fillet weld. And I'm going to line these up end for end flush, apply that. And then I'm going to do my constraints here. If you ever get over, a lot of times I'm expanding out my selections here. If I right click and say collapse all, I can itemize my parts a little bit better and then expand the ones I really want to work with, these two. So I have the planes exposed. And now when I constrain, I can look for the one to pop up. There it is, that one. I want to constrain it to this one right there. I want it to be flush. So okay. So I've got two little weld coupons that are T joints, but we're going to do a fillet weld. And that's just something you have to learn. Like that's probably a new term that we haven't, unless you're a welder, you maybe haven't heard of a fillet weld. I don't know why. I'm just working with standard terminology. I don't know why they call it a fillet weld, but they did. Like I'm going to fill in this corner, I guess, but it's like it looks like a fish fillet, but it's fillet. Yeah, real common entry level weld. And so a fillet weld, though, it goes in here on these corners here, and it just joins these two together. And what we have then is when we weld that together, and he doesn't explain this in the video, but you have some parameters when we set a fillet weld. And so we'll open up that and see what it is. But what it is going to be, a fillet weld is when we have this, we're going to put a little weld in here, join these two together, and almost like a caulk bead. If I wanted to glue them together, I might. Yeah, so what you have in a weldment is that weld tab. So open up weld tab. And then, flash that in real quick. We're just going to pick a welds. Let's see here. Yes, I left click welds. Then it kind of goes, your ribbon menu kind of gets activated there. It's almost like you're in an edit mode here a little bit. Like everything else is grayed out on my model tree because and it has, a welding, it has a weld expandable menu there. Every weld that I apply into an assembly like this is going to kind of be categorized under the weld menu here. And so they're kind of like individual components to this assembly. But once I pick weld, I can pick what type of weld essentially. Here's the weld type. Obviously, there's some preparation I can do and machining, and we will get into using some of these. This initial fillet weld, I don't have to do any like prep other than put the parts together, and the joint kind of is created for me. And then, so I'm not going to even do any machining. I'm just going to go over to now recognizing what kind of weld is kind of critical. But under fillet, there's a lot more than just a fillet anymore. But or I should say under groove, maybe it's a little bit more expandable. But really, they've kind of been able to synthesize this down into just a couple different weld types here, which is cool. I mean, I can create a lot of different welds with just these few simple inputs here. But with cosmetic being my least use, and he does one, but I the point is kind of other than maybe for information in a model. But we're going to do a fillet weld here. Join those two together. It opens up this dialog box, which now you have to start kind of knowing a little bit about welding to apply this in some ways. So what we have here is the bead, okay, and then we have all of these parameters that we can put in here. I think in his book, I don't know what he uses. Does he use 1/4 inch first or something? Let me just see what the kind of weld. Yeah, I think a 1/4 inch fillet. So my selections are just the faces for a fillet weld. Like, where am I going to apply the weld? Well, it's gonna be like on this piece and then on this piece, and it's going to join those two together. So I have two selections here. So selection 1 is ready for me to select, and I don't know what your default is. Mine maybe is what I'll use last, but so I'm going to select this as selection 1, and then I hate that this doesn't just like you'll notice with constraints, it automatically jumps over to selection 2. The weld. This doesn't. You have to come up here and select what is the second face. Well, it's this face here. And then it applies whatever dimension you have in here. There's a 16th. It's going to apply. And so what you're actually applying here is what we call the leg length. If I hover over there, it says leg 1, and this one says leg 2. But I do work this dialog box just kind of like left to right, kind of like left top down to right. So a fillet weld is usually designated by its leg length. And that's not real clear, but what that is on a weld, now that I have a little weld showing up here, it's actually from center right here where the joint really starts out this way. This is the leg length of the weld. And then it's leg length this way. So that's why they have two different leg lengths here. You can do unequal leg welds. And maybe harder to do with one bead, like I'm looking here to make it unequal leg. Like I have to kind of like force the weld onto one or the other. But really common unequal weld lengths are when I'm stacking multiple welds together, because that's what welders do is the welding procedure will say how much weld this needs to have on it. And they'll usually call out on a fillet weld how much leg length it needs. And so for really thick materials, it doesn't mean I make these huge globular welds as a welder. I just actually do more like stringer welds, these little straight line welds, and I just have to layer them up like I would like shingles on a house or something. So I can, like a welder can sit there and layer welds to make long, like wider leg lengths. Multiple passes is what that's called, yes. Thicker materials require that. Thinner materials do not. And here's my rule of thumb that he doesn't discuss here at all. Generally, when you're welding stuff together, a good rule of thumb is that the leg length should match the material. That's a good rule of thumb. It's not always that way, but anything over the material thickness and leg length is over welding the material. So in this case, we have 16th inch thick material. He's applying, I think in the book, a 1/4 inch weld. This would be a situation where design and drafting made a mistake. If they delivered this down to the shop, this would be over welding 16th material. Because he's having you put in a 1/4 inch weld, right? Is that what it is? Or is it 1/8 inch? Which one is it? I think he changes, or he has a couple different welds in here. Let me back up a little bit. I think the first one he does is what? 1/4 inch, right? Yeah, 1/4 inch. Yeah, there's always a caveat and a rule to that. That's my like general rule of thumb is that make your fillet weld leg lengths match at least your material thickness. So in that case, this should only be like a 16th inch leg length, but that's okay. He just puts in, I think, one parameter there, and then he has the contour be flat. And this is the other thing that I like is that in a welding environment, in a metal welding environment, the weld inspectors are going to make sure that the leg length has been met. They have like a little caliper they can put on here and measure that leg length. And that's how a weld inspector will come on, and with these like actual manual tools will apply them and see if the leg length matches. And then they'll also check that there is at least like this. They call this the throat of the weld. From kind of where the weld joint is up to this surface right here is called the throat of the weld. And at this point, like in a metal environment, they need this to at least be flush like this. They do not like it to be concave. They don't like the throats to be concave. So they like to make sure that your leg lengths are the right length and that the throat is at least flat like this, like triangular. They will allow it to be convex to a point, but there is a limitation on how convex it can be because excessive throat can cause material failures, not your weld failure. Your weld is this huge bead, but its excessive throat thickness causes sometimes undue stress on the material, and it does lead to material failures. So with plastics, I think this is more like a convex contour shape like this is maybe more common in a plastic welding environment. But in metal, it's really excessive reinforcement, we call it. And so like for a lot of like metal welding, and if I was showing them visually, I'd probably show them at least like this. And there would be rare instances that I would show a concave. Yeah, like usually this like the welder can't really like in some cases the welder can't control they can control it a little bit. They have to be aware of it, but a welder's usually going to shoot for just slightly convex and just so they can avoid this concave finish potentially that could disqualify a weld. But what I'm saying is there are some situations where like I think of like dairy equipment. Think of a dairy industry and like a cold like fluid in a stainless steel container. They don't like to have like big weld beads in there, and they will polish those out smooth. If you think of like in food processing or in other applications, yeah, sometimes like the inside of stuff has to be like no cracks. We don't want any like places where bacteria could seep in. But then we don't need the structural integrity because maybe the design holds up the integrity better. And all I need is like a sealed weld, and then it can be like polished out really smooth and clean. And then it does end up having a concave profile, but it's more for like sanitary reasons. And kitchen sinks can be that way too. Like there's not a lot of structural integrity we're trying to get like bacteria traps eliminated. Sanitization is more key than structural integrity maybe. And so there are reasons why. So I say that it's cool that they have these options because I can kind of show that profile. I'm going to pick this one because the general rule of thumb is welders don't do like convex welds unless there's a real good reason for it. And it's more cosmetic. So okay, and I think that's all they do here. He doesn't worry about any of this other stuff yet, but we can kind of change. We can set up the how long the weld is, and then how to stagger those like little weld sections, and we can even offset it from one end of this to the other, and uh, and that's sometimes critical in I-beam situations. There are reasons why I wouldn't weld out to the flange. I can ruin metal. So I mean, there's reasons why I can like change all the parameters of this weld and kind of the direction of it. Yeah, this is kind of an equal leg fillet. I think that's what this is. This is selecting right here. I think this is this is the throat measurement. If I want to specify the weld by throat measurement, like I just said, that's what that would be, the throat thickness. I'm doing by leg length. And I think even if I don't apply a leg length to dimension, it puts it in as an equal leg length. So, I mean, if I put in 0.25 there, it is an equal leg length, but that's where I could specify an unequal leg length. And I think this is it for this one. He hits apply on this. And then by default, maybe yours, hopefully like mine, my default does show it looking like a weld. However, it showed the best default, like uh, it's calling it a welded aluminum 6061. 6061 is a type of aluminum. So this isn't necessarily what this is. I haven't even really specified what this material is, but I think the default in a weldment, it shows it as aluminum just because it is the only like property they have default set that shows like what a weld looks like a little bit on top like this, has like little ripples in it like a weld does have. And that's just the freezing and cooling cycles of the weld as this person's like welded along, causes ripples. So I'm going to leave that, even though maybe I would need to be more careful here because that considers that this is an aluminum weld. But I think I don't know what the next weld you guys here. Still pretty good. I think they just do an 1/8 inch one, maybe. Did it end up being an 1/8 inch only? Yeah, I think the first one was actually an 8th, right? No, quarter. And then he does an 1/8 inch convex right here. So we do another weld. So this one ended up landing right here. This is if I expand this menu out, here's my fillet weld one. and I'm still in the weld. I'm still activating this. I don't go back to the assembly until I go return, and then I would be back into where I have access to all of my model parameters in the assembly. So I'm gonna go back into welds though and do some more welding here. Maybe another fillet weld. And we're gonna go, this face is one, this face is two, second face. That's the annoying thing about me is just remembering to select the other face. I think he makes this one just point. And the other one, but the same side. Yeah. And then I don't know if he changes anything. I think he just changes it to like a convex weld here. In his video, he maybe shows it looks like he has an offset of a 16th of an inch. I'm not sure if he did that. I think that's all he does to this one. He says okay. So there's a difference in the convex weld, a little bit shorter profile. Really, really, it almost looks like a bead of plastic, but severely convex. Yeah, but yeah. Oh, maybe I don't know. Probably just an order of operations thing. So I think the biggest thing that I feel, if I undo mine here, like the biggest thing I always fail at in this is just remembering to toggle between your two selections. Yes, because if you select this as one and then you say okay, or it won't even let you if you have them wrong. But oh, convex, concave. Oh, it won't allow you. It's like the reason why it says no is because yeah, it's convex and maybe it breaks. It can't like the with an eighth inch weld and how much room it needs. It's like not compatible with this program, even though it probably could be done in real life actually. But so it doesn't have I guess the dimensional constraints like make it so it can't. It could do these other two though. Okay. Yeah, like oh well, it would be yeah, I think yeah, if you did some, you could do some weld prep into it. We could actually V into those that one, like we could V, yeah, like what you're saying is if I V'd into this a little bit and then applied a weld, then I could grind it all the way out and I would still leave some residual deposit of weld in there, right? And that would be an application where I could create a 90-degree corner that is sanitary, but really maintains its yeah. No, that's interesting. Yeah, yeah, it would be best specified with just a weld symbol and with the note in the tail, like with a reference note saying grind to 90 degrees or something, right? You could and so whether what you probably can't display that here. I think we end up it needs to wants to unless you do it as a cosmetic, which would be the option there. Even though the cosmetic weld doesn't end up looking like what it's going to look like, you know. So it's just like it's actually just like an indicator that there is a weld there, and then you could establish some parameters to the cosmetic weld that could be shared with somebody, right? But I think that would be definitely best specified just with the welding symbol. Yeah, and actually, hey, you're right on the money though. If I do V this in here and do some weld prep, you're actually falling into a groove type weld and not a fillet type. So absolutely. And we could do that and it would actually show as flush finished. Yeah. So and we do some of those actually. So that's good point. Yeah. Yeah. Like on the end here, it's a constraint, right? Yeah, I have three constraints driving my parts. I'll finish that well, by the way, so I'm gonna finish that one. Yeah, it would just be a constraint that you're missing. I have three constraints on all mine: face to face, flush end, face to face, and then center to center plane. So I've got three different constraints. 3D world, three constraints. Checking. Good thing we're not in the seventh dimension. I don't even know how to. I don't even know how to constrain, and even the fourth dimension. Oh, good. Yeah. We can get a feel for that with. Yeah. He flips these over and does a couple more welds on this side. It is common that things sometimes do need welded on both sides. Sometimes they need only welded on one side and then like stitch welded on the other. So welding sequences get pretty particular on how to, how things need to be welded. And so what I'm saying is these don't necessarily make sense to an actual welder, what we've done here so far. But it is fun to play around with just the program and what it can do. So, and that's why I think the value is here is just getting familiar with this. We can try to make our stuff make a little more sense as we actually apply the in our other problems here, but that we'll work on this week. So he just does what, a couple more. He does this side. I think he does. I don't know what something. I look at the numbers. He does just more fillet welds. Oh, he does like a 1/4 inch concave. I really think this first one I've got wrong, and it's easy to edit though. Like I think his first one was really 1/8 of an inch, one convex, one concave, maybe. But so if I edit this, which you can go into here and edit it right from the model browser, I'm going to edit this feature. Goes back into that dialog box, and if I made a mistake, it's supposed to be 125. It's pretty. That's an easy change on this one. I think that's what he does because on this side of this one, he does like a 1/4 inch weld. So he does another weld in fillet mode. And he does this face still to this face here. And then these become 1/4 inch welds. And he also does that concave profile here. I think just to show it. If he wasn't bigger, he couldn't actually show that. And that's what the offset must be set that. That must automatically have set that. I didn't type anything. But his book shows it to you. He just okays on that one, so he shows a convex. Well, I could have hit apply and then another one. It may look different from one side to the other side too. 1/4 inch like in. So then this other side here, what do we do? I can't remember what he does. Let's see. Oh, he does the cosmetic one, which to me is more for information only. Like this would be a way that I would like not show the weld. I think that really, if you look up like why Inventor has this functionality, is what it is this. It's like a cosmetic weld. And you're going to say that, hey, this like it's kind of like an edge or seam or an edge or a seam, I should say. And so in this one here, he applies a cosmetic weld to this. I think he just left the area the same. He said, okay, apply. And it just puts an orange line in there. But I think it's just to show that there is a weld that will take place here. I don't really know how, I've never used this for any of my own design purposes, this cosmetic weld concept, but it really just like it shows your model that something is going on there. It's a weld, like it's a welded joint, but it's not really showing the level of detail that the weld, um, the actually applying the weld. It's definitely a smaller file size for one. And it's maybe a way to visually show that, hey, those two parts, there's a weld going on there. And maybe on your drawing, it should be an indicator that I should have a weld symbol associated with that. Then maybe it's a way to track that. I don't know. But it is just a way to point out there's a weld there and not really call out much else. But because it doesn't tell you what kind or anything, but your weld symbol. And it's just this like visual indicator on your. But does it go away? No, it stays there. When I exit that, I just said return. Now back in the model browser. To me, it's like a visual indicator on my assembly of where a weld might be. But on some metal parts, that'd be like all over every seam, and so maybe that's too redundant. But I don't know. Yeah, you definitely get that, especially when I teach hobbyists. Yes, but yeah, it is pretty common a welder will then start welding with their initials. If you leave them too long unattended, yeah, you will get some awesome creations. And it's kind of fun. Because what's why once you got a straight line down, just go ahead and no, it is funny to teach welding because people just want to move on, but you're like, actually, you have to practice. You're kind of looking for perfection in practice. But a lot of people, it takes a lot of the same thing over and over, right? So it takes a lot of practice. Yeah, it's exactly like learning a language. It really is just a practice skill, right? Super learnable. He shows you the weld calculator, which is interesting. I think I have to maybe would have to select the weld, but I think he says fillet weld calculator plane. I haven't, like it's not super common for me in my industry to have had to apply the welds in a weldment. So using the calculator is not something I'm not very efficient with at all, actually. But I can see the point of it would be if I bring this up. Oh, I have to save it, so it'll give me that. It'll give me the option to save mine. Mine's in assembly, so I'm gonna save mine in my assemblies file. It's like my chapter one assembly, my chapter assembly. So I definitely need you to save that file. And then it brings up this dialog box. This is just one of the many you could have chose to weld calculate. But the why I see this is I think you can see that there's some forces, so some engineering behind this. My question is here, I'm not sure which weld this is evaluating I have a bunch of different welds there, so I don't exactly know what weld this is calculating for me. Or if I have to select it, I don't know. I'd have to play around with this a little bit. He just opens it up to show you there's a lot of there's some engineering and some numbers I could pull out of here, but these are all mostly have to do with strength here. I have a weld height and a weld length is 4 inches. Okay. I think I can also in this weld calculator should be able to calculate like how much weld deposit I'm going to make, and I could order materials from that. So there's some sense in this. Like I could like explore a design and see how much cost is going to be associated with which different material types. So if I was exploring different welding processes to save some money, could I use these welding calculators? Absolutely. I could explore design and I could also explore their strength and their loads. So yeah, I don't know. It's just interesting. I just haven't played around with it a lot, and it's interesting to me. There's a lot of different ways. I guess it depends on which type of welding I'm evaluating here. But for me to use that here is weird because I just have quite a few different welds going on, and I get most assemblies will. But anyway, essentially these have been over welded on. So this would not be how I'd want to send something to a welder. They would freak out. And that's what I mean. You get into this area where you just, if you don't know, you don't know, and it's hard to determine someone's work on your drawing by if you don't know the situation. So it's dangerous. And I specifically worked in a place where they were stripping weld symbols off because they had just been raked over the coals by fabrication. Instead of just helping us all get it all figured out, they were just stripping them off their prints. Like these you cannot get. Oh yeah. Oh, I don't know. Well, it could be how you so yeah, yeah, one thing you maybe have not noticed is that on my part itself, when I did the extrusion, I'm actually centered over this way. Is that how yours is? Oh, okay, but that's not it. I don't know. Like, let me place a couple more and see. I will place these in my assembly here just to see what I did different. So I had these two parts. I just went into constraints. I think I chose this edge to this face. Snap that. That's good. I said apply. And then I did the end for end here. End for end. I didn't like that, so I need some flush. Bam, that solution. Then I hit apply. And then I just did the planes. So then I found their planes in the browser, which is really common for me. I look for a lot of plane alignment in my parts, really. There's the plane on that part, but I want to align. So there are different planes on these parts, actually. It's just that I kind of almost like, yeah, you can get so so yeah, if you don't have the plane on that one in the right place, yeah, it's probably I'll open that up again. It's where I constrained if I go into my actual sketch, you'll notice this also. I've actually centered mine over the so if you didn't do this, you won't have the planes in the center either. You see me do this a lot when I have a simple part. Like I just constrain it over the origin. But but when parts work off parts, I can't always do that. So I kind of mislead you thinking that I'm always gonna do plane to plane to plane to plane. I just do it when I know that my part had no relationship to anything. So I could just choose to center it over the origin point. And I will do that. Like if I have a part that I'm just designing and it doesn't matter, it's not in relationship to any other parts, I'll just center it over the origin point 9 times out of 10 probably. And then it just puts my planes as a selectable item in my assembly for centering it. And that's pretty common. But there are times when I'm working, working from an assembly and creating parts, more of an assembly way of creating parts, which we haven't done much of. But we're gonna do it on the pipe support problem. Then I can't use that as much. I might be able to use one or two of the planes at times, but not maybe not all three of them. So, and technically in this assembly, I didn't use all three planes. I kind of did use some face to face, and I only used one set of that we're gonna. So, and it wouldn't matter. You could dimensionally have constrained this too if you could have found center. He doesn't dimension. He doesn't put his on center. He does like a 0.5 inch offset dimension, so his aren't even centered. Uh, yeah, and this is all for that. And this is that. Um, so that's cool. That was exercise 5. And so I think it's just a matter of submitting the part in the assembly here. I don't know. So I'll finish this. This is the end of that. Save it and upload those 2 files. Should just be one part file, one assembly. It's a Weldment assembly. It's still, oh, no, one notice the thing too is even though it's called a Weldment, it still is just a .iam file. So there's not a different file type for Weldment. So you can't necessarily recognize them from just looking at the folders. You may have to open it up and then it would have this weld tab here and you know that you're in a Weldment. And it's less common in real industry to even do Weldments unless you have real specific reasons. And yeah. But to weld calculate would be cool because I could just bring an assembly in here and apply the welds that I'm going to do, and then I could calculate volume of welding material needing to order. And so I could see that, like, even though I might not save that, it could be an analysis. I could use a weldment for an analysis reason, and even to check strength and loads and stuff. Yeah, that's cool. So I could see myself doing that, doing more of like a design refinement. Bring my already assembled assembly into here, apply the welds, and then just really calculate weld stuff. And then I could save that as a Weldment file. It's mostly for calculation purposes, not necessarily for my prints or whatever. So yeah, good. As a weld, I think I can insert it into a Weldment. Yeah, because you can. That's a good question. You can insert. You can insert